Hi, I'm Joe Aguilar, an applications engineer at Vicor Corporation. Today I'll be demonstrating Vicor's new selection and IBC simulation tool, the first in the industry. This new tool enables engineers to model the electrical and thermal performance of IBCs in application-specific operating conditions and thermal environments, helping them quickly select and model power system designs. Let me show you how it works. To start, the essential variables are entered. As an example, we'll enter 38 volts as a minimum, 48 volts as a nominal, and 55 volts as a maximum input voltage. We then select fixed ratio for the regulation type, where the output will track the input by a defined ratio. We now get a drop-down menu with all conversion factors that are available for the given input voltage range. After selecting a conversion factor of 1/5, you will see that the output voltages are automatically populated based on your input voltages and your conversion factor. We will now choose an output power of 300 watts and select that isolation is required. Hit the Search for Solutions button and the tool will calculate solution options based on your parameters. Here are all the solutions with a conversion factor of 1/5 that fit within your given criteria. Results are displayed in a table format with the ability to easily sort, filter, and compare your results. Let's take a quick tour of the results window. For each solution, the part number is shown, as well as how many parts are required. Key parameters for the solution, such as efficiency, density, and cost, are shown. The list of solutions can be sorted or filtered by any of the columns that have these icons. When these results are first shown, the default sort order is by power density, as indicated by the blue highlighted arrow. At the top, you'll see an icon that allows you to export these results to Microsoft Excel. Click on the Show Hide Columns button, and you'll see an easy way to customize your results. We have grouped the columns by electrical, mechanical, and other functions. You can easily turn on and off an individual column or an entire group of columns. On the left, you have the ability to compare the different solutions that are displayed by clicking the checkboxes and hitting the Compare button. You can order prototype quantities by adding the solution to the cart or by calling Vicor. We've chosen our solution, now let's simulate it. Click on the Simulate icon for this particular IBC to launch the simulator. We've now entered the simulation tool. At the top of the page, the part number is displayed, as well as a drop-down menu for simulation type and an entry box for simulation time. We offer 7 types of simulation: thermal, steady state, VN startup, VN step, load step, enable startup, and enable shutdown. For this demo, we'll choose a thermal simulation. Below, you will see the reference design for the simulation type selected. The reference design contains an input source, input filter, output filter, and load. Any of the blue fields in the schematic can be changed by clicking it and changing the value. In the middle, you'll see the IBC, and in certain simulation types, such as this, you can change the thermal parameters by clicking on the input fields. We'll change the ambient temperature to 50 degrees C, airflow to 600 linear feet per minute, then change the load to 60 amps. When you hit the Simulate button, you're presented with a table displaying the steady-state electrical and thermal characteristics. This table includes parameters such as operating temperature, efficiency, output resistance, and output voltage at the conditions defined by the simulator. Below the table are 4 sets of waveforms. Each waveform represents a probe point on the reference design. The first graph contains the Vout and the Vload waveforms, showing the voltage directly at the output of the IBC and directly at the load after the filter. You can turn the waveforms on and off by clicking on the legend. You can zoom into a specific area by clicking and dragging. You can pan by clicking and dragging with the right mouse button. If you hit toggle cursors, cursors are added to the window. If you wish to make a measurement, you can position the cursors and then view the delta X and the delta Y values on the bottom right of the display. At the top of the waveforms, you will see two buttons: Store Waveforms for Comparison and Compare Waveforms. Clicking on the Store Waveforms for Comparison button stores the current simulation results. If we make an adjustment to the reference design by changing the airflow to 400 LFM and changing the load current to 30 amps, then resimulate, the Compare Waveforms button becomes active. Click on the Compare Waveforms button and you will see the stored results in addition to the current simulation results for comparison. Thank you for taking the time to get acquainted with this new tool. With the ability to easily select, simulate, and optimize IBC designs for intermediate bus architecture power systems, we expect this tool will help power system engineers accelerate design cycles and achieve better competitive results.